So looking at this lesson, we're going to be looking at how to divide polynomials. So this is going to kind of take you back to how you used to do long divisions with numbers in elementary and or middle school. But we're just going to be doing it with polynomials. So the algorithm is the same. So think back to how you used to divide numbers. And we're going to do that, but we're going to do this with polynomials. So here, to use the long division algorithm, see that I have 4x to the fourth minus 5x squared plus 2x plus 2. Now, there is something important here. As I write this to do my division problem, I'm actually going to put a 0x to the third after the 4x to the fourth. And the reason is that as I start multiplying things out, even though there wasn't x to the third in the original equation, I may need to line a term up with that or combine like terms. And so it's just going to help me avoid mistakes so that I don't actually line something up with the wrong term that it's not like with and, kind of don't pay attention and then accidentally use that when it shouldn't be used. And then I'm dividing this by 2x minus 1. So here's what we're going to look at. We're basically trying to figure out what do we want to multiply times 2x minus 1 to make this giant polynomial. So we're first going to concentrate on the first term. What would we multiply times 2x to make this 4x to the fourth right here? So my choice then is going to be 2x to the third, because 2x to the third times 2x would make 4x to the fourth. But now when I multiply it, so remember in division, after you've picked this term up here, you multiply it times your divisor, and then you write it underneath to subtract in your long division process. So I am now multiplying 2x to the third times this entire 2x minus 1 divisor. So that's going to give me 4x to the fourth, which is what I wanted, minus 2x to the third. Now remember in division, once you've decided what number goes there, you're subtracting this quantity from the quantity that was already in your problem. So subtraction with polynomials, remember, is like addition if I distribute the negative sign throughout. So then the 4x to the fourth will cancel. I'll have positive 2x to the third left, and I'll drop down the next term, which is negative 5x squared. And now I kind of start the process over again. I ask myself, okay, what would be the next thing that I would multiply times 2x to try and obtain 2x to the third? So that would be x squared. And once I make that decision, that x squared needs to be distributed to this entire 2x minus 1. So x squared times 2x will give me 2x to the third, which is what I wanted. And x squared times negative 1 will give me negative x squared. Again, once we do this, remember that we're doing the process of subtraction here. And subtracting a polynomial is the same thing as adding the polynomial if you have distributed the negative to each of the terms. So the 2x cubes will cancel out, and I'll have negative 5x squared plus x squared, which is negative 4x squared. Then I'll go ahead and drop down the next term, which is a plus 2x, and start the process over again. I will ask myself, what would I want here so that when multiplied with 2x, it would make negative 4x squared? So that would be negative 2x. And then I'm going to multiply that negative 2x through my entire divisor, that 2x minus 1. So negative 2x times 2x is negative 4x squared. And negative 2x times negative 1 is positive 2x. And then remember again, once you've written that down, you're subtracting this polynomial from the one above it, which is the same as adding if you distribute the negatives. Now here, both these terms cancel out, which means you have 0. And then you're dropping down a plus 4. Now, we have finally gotten to the point where the degree of what we have down here, which is basically just 4, is less than the degree of our divisor. So the degree of our divisor is 1. So unless we put an x in the denominator, which breaks the rules of polynomials, there's no way we can multiply to make that. So now we're ready to answer the question. We're done with our division problem. We have this portion here. Here's how many times 2x minus 1 goes into this polynomial. But it has this remainder or this leftover of 4. So let's think about how we write that. So the first question is, what is the quotient? The quotient is the answer to the division problem. So basically, the quotient is 2x to the third plus x squared minus 2x plus this extra remainder of 4. So remember how we can write that. We can put 4 over whatever we were dividing by, and in this case, that's 2x minus 1. So this is one way to write the solution. So that's when we wanted the quotient, the answer to the division problem. If they asked us just what the remainder was, we would say 4. Okay? So 4 represents the remainder. The quotient would be written how you see up there. All right. So if we were in class, I would race you guys at this division problem, but I'm going to show you why I would race you next. So here's a way of doing synthetic division. So it's kind of like this idea of the quadratic formula. The quadratic formula comes from the process of completing the square, and the completing the square process has certain steps that you do. Division has the same steps that you do over and over again. Because it has that algorithm, this process that you keep repeating to find the answer, they can kind of summarize the process and take out all of the extra stuff. So all the x's that you're doing and stuff like that, they can take that out, and then they can go ahead instead and just put in the numbers, and they can look at the numbers and see the answer. So here's how we would do it. The setup looks like this. First, you're thinking, what am I dividing by? And you're basically thinking about the 0 of the divisor. In other words, our divisor, the thing doing the dividing, is x minus 3. The 0 of that factor, okay, if we set it equal to 0, is that x would be 3. 3 is the number I'm looking at plugging into these other numbers. And what I want to do is I want to compare that to the coefficients of the dividend, the thing that's being divided. So the 6x cubed minus 19x squared plus x plus 6. So what I want is all the coefficients. And just like with long division, if it's missing a certain power in the standard form of the polynomial, I would put in a 0 placeholder. But it goes from x to the third to x to the second, x to the first, and constant. So it has a term from highest to lowest power, so we're fine. So the coefficients are 6, negative 19, 1, and 6. And I'm going to leave a line of space and put this line here. So basically, I'm going to do a bunch of multiplication and addition, which is going to simulate the division process. So here's how this process works. The first thing you do is you just drop down the lead coefficient, which is 6. You then multiply that by the number in the box. So any number that ends up in this row down here needs to get multiplied by that 0 of the divisor, in our case 3. So 6 times 3 is 18. The product from that multiplication problem goes in the next column, and every time you fill up a column, you add up the column. So negative 19 plus 18 is negative 1. Again, a number's down here. I multiply by 3. So negative 1 times 3 is negative 3, and then I add up the column. 1 plus negative 3 would be negative 2. Negative 2 times 3 is negative 6, and I add up the column, and I have 0. Okay. So we have to learn the process. But more important than the process is that after we do the process, we need to understand where the answer is. Okay? So this row that you created down here are basically the coefficients to the answer, where this represents your remainder, your constant, the coefficient of x to the first power, x to the second power, and if you had more terms, you would have more places. It makes sense that the highest thing you're going to have is x to the second power because your division problem was taking something with x to the third power and dividing it by x. Think about that for a minute. If you didn't have all the other stuff and you just took x to the third power and divided it by x, you would then get something with x to the second power. So our quotient, our answer to the division problem is 6x squared minus x minus 2, and there's no remainder, so I don't need to write that part. That's the answer to the division problem. Okay? So we're going to do the synthetic process with the same problem that we did previously with long division. The reason I want to show this to you is it works a little bit differently when you have a coefficient in front of x. Like see how our divisor has 2x minus 1? We have to treat that a little bit differently. This synthetic division process, kind of like completing the square, only works if that lead coefficient of your divisor is 1, and you have to be using a linear factor. So 2x minus 1 is a linear factor because it has degree 1, but it's not how we want it because it has a lead coefficient of 2. So basically, think about it like simplifying a fraction. You have this polynomial being divided by 2x minus 1. If I don't want this 2 right here, basically what I can do is I can divide the denominator of the fraction by 2 as long as I do the same thing in the numerator. Okay? And so now this is going to look like x minus 1/2 in the denominator. And in the numerator, it's going to be 2x to the 4th minus 5 over 2x squared plus x plus 2. Everything in the numerator and the denominator was divided by 2. Now, this division problem should be the same as any other division problem. Because remember, 3 over 6, if each of these are divisible by 3, is the same thing as 1 over 2. So that means 3 divided by 6 is the same thing as 1 divided by 2. So I'm using that same idea here. So I'm going to do this division problem instead because I can't use synthetic division unless this lead coefficient right here is 1. Okay? So remember how we set this up. What's the 0 of what you're dividing by? So if I took x minus 1/2 and I set it equal to 0, I would get that x is equal to 1/2. And then I want all the coefficients in their standard form order of my polynomial that's being divided. So this guy right here. And remember to include 0 placeholders wherever a power is missing. So I have the first term is of degree 4, and its coefficient is 2. There is no term of degree 3, so I'm going to put a 0 placeholder for that. The term with degree 2 has a coefficient of negative 5 over 2. The term with degree 1 has a coefficient of 1, and the constant is 2. And I'm going to go through that same process I went through before. So first I'm going to drop down the lead coefficient of 2. I'm going to multiply 2 times 1/2, which would give me 1. That goes in the next column, and I add up the column. I then take that sum, 1, multiply it times 1/2. That gives me 1/2. I add up the column. So this gives me negative 4 over 2. That's really the same thing as negative 2. I'm going to take that and multiply negative 1/2, which gives me negative 1. 1 times negative 1 is 0. 0 times 1/2 is 0, okay? And I get 2. So remember how we do this. Either count back from the constant, or remember that you were taking something that was x to the 4th, and you were dividing it by x to the 1st, which means you should end up with something that has degree of 3. Now this will be our x squared, our x, our constant, and our remainder. Okay? This means that our quotient is going to be 2x cubed plus x squared minus 2x. There is no constant, so I don't need to write it. And my remainder is 2. Remember that that remainder needs to be over what you were dividing by, which was x minus 1/2. Now, this does not look exactly like the answer we had before if you look back here. Okay? Everything looks the same except for this remainder part right here. We don't have 4 over 2x minus 1, and here's why. We have 2 over x minus 1/2. Now, here's the thing. To write this properly, we don't really keep fractions within fractions. So when I look at this remainder and I notice that it has a fraction within the fraction, I want to get rid of that. So in order to do that, I want to multiply this by 2 so there will no longer be a fraction. I can only do that within this fraction if I also then multiply the numerator by 2. So my final answer then is 2x to the 3rd plus x squared minus 2x plus 4 over 2x minus 1, which is the same as what we had before. So you've seen 2 ways to do this, long division and synthetic division. Synthetic division is a handy tool, but is definitely more handy if you have a problem like problem A, where the divisor is already ready to go. Okay? It already has a lead coefficient of 1. A little more difficult in something like problem B. Okay, so why is this important? What do we want to do? So notice here it says to use f of 2 using synthetic substitution. So I'm going to show you guys 2 things. Normally you would calculate f of 2 by taking the f function and plugging 2 in wherever x is. Okay? And if we do this, let's see. We get 16 times 2, so we get 32 plus 8 minus 12 minus 5. So 32 plus 8 is 40. 40 minus 12 is 28. Minus 5 is 23. Okay. Now watch this. If 2 is the number that I use inside my box in my synthetic substitution with this polynomial, so lead coefficient is 2. The next one's 1, negative 3. We're missing the term that has just x to the first power, so 0 placeholder, and negative 5. So if I plug 2 into this process, remember the process, multiply when it's below and then add as you're going. Notice that we also get 23 right here. So not only can synthetic division be a division process, but it also emulates plugging a number in. So you can either calculate f of 2 like this, or you can make 2 the number right here and look at your remainder to see that f of 2 would be 23. So f of 2 is 23. Based on my synthetic division, when I took f of x and divided it by x minus 2, I got this quotient, which remember, I took something to the fourth power, divided it by something with the first power, so this should be x to the third, x squared, x constant remainder, which means my solution here is 2x to the third. This is my quotient, my answer to the division problem. 5x squared plus 7x plus 14 plus 23 over x minus 2. X minus 2 would be the value that would have to be there. 1, because it said we were dividing by x minus 2. And that's the only way 2 would be the number in our synthetic division process. Okay, the remainder when f of x was divided by x minus 2. Is x minus 2 a factor of f of x? Okay. So think about this. Is 3 a factor of 6? Yes, because 6 divided by 3 is 2 with no remainder. Okay? So things that are factors of other numbers, when you divide them, leave no remainder. When we divided x minus 2 into this function, we got a remainder of 23. So since there is a remainder, then x minus 2 is not a factor. Then is 2 a 0? So remember, our factor theorem said this would be a factor if this is a 0. So if we know that this is not a factor, then we know 2 is not a 0. We can also know that because if 2 was a 0, that would literally mean if we plug 2 into the function, we should get 0, which is not the case here. Okay. Then it says, is 2 a solution? Remember that solution is another name for x-intercept or 0, so if our answer to E was no, then our answer to F would also be no. Okay. So synthetic division, besides giving us the answer to a division problem, also can allow us to see the result when a number is plugged in, and also allows us to quickly see if there's a remainder to know if something is or isn't a factor of a polynomial. All right, so here is another problem. If we take this polynomial and divide by x plus 2. So remember, if you're dividing by x plus 2, you think about what that would be when it's set equal to 0. That would be negative 2. So it's like you're plugging negative 2 into the function. We're going to use the coefficients. No 0 placeholder because it didn't skip any powers of x in our polynomial in standard form. We're going to drop down the first coefficient. We're going to multiply and then add. We're going to continue that process until we reach the end of our division problem. Now remember that we took something that was to the third power and divided by the first power, so we should end up with something to the second power, which would be our constant and our remainder. So the first question says, A says, what is f of negative 2? Well, remember what we saw last time. Plugging in that number, I can go back and plug it in, but my remainder tells me the answer. So f of negative 2 is equal to 0. So is negative 2 a solution of f of x? Is it an x-intercept? When you plug in this x value, do you get 0 for y? And we see that we did here. We plugged in this x, we got 0 for y. So it is a 0. It is an x-intercept. It is a real solution to this problem. So the answer for part B would be yes. Is x plus 2 a factor? So remember what our factor theorem said. If this number is plugged in and creates a 0, then x minus that number, which would look like x plus 2, is a factor. So yes, this is a factor. What part D says, what is f of x divided by x plus 2? So I'm going to look across this row and pay attention to the powers of x to write the quotient. So this is x squared minus 3x minus 4. And then it says to rewrite f of x in factored form. So remember what this means. Think about numbers. If you took 6 and you divided it by 3 and you knew the answer was 2, A way to write 6 in factored form would be there's a factor of 3 times a factor of 2. Okay? So we took f of x and we divided it by x plus 2, which was a factor. So one factor was x plus 2. What does x plus 2 multiply to get back f of x? It multiplies the answer to our division problem, which was x squared minus 3x minus 4. And then the question is, can that be factored more? And it can. X squared minus 3x minus 4 factors to x minus 4 times x plus 1. So this is the factored form of f of x. So now we find yet another use for this synthetic division. If we see that something is a factor or divides in evenly or has a remainder of 0, it can help us factor a polynomial of higher degree. Okay? Then it says, what are the other zeros besides negative 2? So we already set this factor in and knew that negative 2 was a 0. But each of these other factors would create a 0 too. So if we set x minus 4 equal to 0, we get that x could equal 4. If we set x plus 1 equal to 0, we get that x could equal negative 1. So there are 2 other zeros, 3 in total. And then part G says, sketch the graph of the function using the zeros. So remember what we're looking for here. Correct shape, correct end behavior, crossing through the right zeros. So our zeros existed at 4, negative 1, and negative 2. And look at our original function. It's a cubic, and it has a positive lead coefficient, so I expect some shape like this. So I'm going to make this shape with this end behavior fit these zeros. So something like this. Again, my relative maximum and minimum are probably not correct, but I'm not concerned about that. I'm concerned about shape, end behavior, and zeros. Okay. All right, so I want you guys to write this down on your paper and bring it to class. And then we're going to compare with your groups and share out. What is a zero of a function? Include a description that relates to the algebra / arithmetic and also the graph. Second question, how is the zero of a function related to a factor of the function? Third question, how do you determine the maximum number of complex solutions that a polynomial function can have? So that's an interesting statement. Write down what you think, bring it, talk to your group tomorrow, and then we're going to talk about it in class together. All right, so here's a problem where we could apply these skills. Let's say there's a polynomial that x cubed plus 9x squared plus 23x plus 15 is the volume in cubic inches of a box, and you know the length of the box is x plus 5. So a couple of things that we know here. Sorry, my box drawing is not that great. So we have a box. It says the length is x plus 5. We know that the volume is this other polynomial, and that volume would be obtained by like a length times a width times a height. So we want the other 2 dimensions of the box, like what is this and what is this. Okay? So plugging into this equation, I know that the volume is x cubed plus 9x squared plus 23x plus 15. And I know that the length is x plus 5, and I'm looking for both the width and the height. So here, if I was going to solve this equation, I would want to divide by x plus 5 to at least get the width times the height alone. So I want to do this cubic divided by x plus 5. So I'm going to use synthetic division. So negative 5 is going to go in here because that's what x plus 5 would be set equal to 0. My coefficients are 1, 9, 23, and 15. And hopefully it goes in evenly. So I drop down the 1, I multiply, I add, I multiply, I add, I multiply, and I add. So this is really good for me because the remainder being 0 means that it goes in evenly, and that basically the answer to the division problem is going to be x squared plus 4x plus 3. And that still means that's the width times the height. Okay? So I basically finished this off. This was the answer to our division problem. We canceled this. We still have left our width times our height. So then the question would be, could I factor this? Because this would be great. And it does factor, x plus 3 times x plus 1. And that's our width times our height. I don't know which one is technically which, but I do know the other 2 dimensions of the box are these 2 things. Okay? All right, so make sure you answer those previous questions and bring them with you to class so that we can discuss this and then work on the homework that goes with it.